Okay, we're doing homework examples in R.3 again, and this is numbers 42, 48, 50, 52, and 58. So let's see, this time we are adding with addition unique common denominators. First of all, they both have a p in common, but they have a 4 and a 5. The common denominator between a 4 and a 5, they both go into 20. So this one, to make a 20, needs to be multiplied by 4, but whatever you do to the denominator, you have to do the numerator. This one needs to be multiplied by 5, and again, numerator times 5. And that leaves us with, now at this point in time, I'm going to show this step, but for the remainder of the video, I may be cutting this kind of short on here, instead of showing every little bit. This is 32 over 20p plus 15 over 20p, which equals 32 plus 15, which is 47 over the common denominator of 20p. And this one is reduced. You can't reduce a 47, that's for sure, and that completes number 42. Now, if it was my own paper, I would have looked at this and said this is 32 plus 15, and I would have wrote 47. And I would have said, well, these have a common denominator of 20p. So I would have completely left out this step. As long as this work is over here to prove what I'm doing, that is an okay step. So I'm on to number 48. 3 fractions here. They all have p already in common, but 3, 4, and 2 all go into 12. So that means I'm going to have to multiply this one by 4, both numerator and denominator, to make it 12. This one by 3, both numerator and denominator, and this one by 6, both numerator and denominator. So again, all of this now is going to be over 12p, but I'll write it out. 32 over 12p plus 15 over 12p plus 54 over 12p. And let's see, adding all of this up, first of all, we know the common denominator is 12p. We have 32 plus 15, which again is 47. 47 plus 54. Well, if I add 50 onto 47, I'm on to 97, plus 4 more gets us 101. Now, your final answer for number 48. Let me just make sure everything is done correctly. Yes, it is 101 over 12p. And that completes number 48. Now we have number 50. Number 50, this time it's going to change. You're going to have a plus sign and a minus sign. And these denominators look so close to being the same, but they're not. They're not. Chunks, you have to think of chunks with plus and minus signs. If this has x plus z, this has to have an x plus z. There's no other choice. So, and this has an x minus z, this has to have an x minus z. There's no other choice. What that means is this fraction needs entirely x minus z. And it needs that both numerator and denominator, the x minus z. This fraction needs entirely the x plus z, both numerator and denominator. So we have to see what's left here now, okay? First of all, I want to tell you that these denominators are now exactly the same. They are x minus z over, or x minus z times x plus z. That's what both denominators are. And you will not be multiplying these back together again, because we're going to need these separated to find things like domain, like in those first few problems in this section. So leave these separated. You do not put these back together. Over here, you can distribute the 1, which just gives us x minus z. Then you have this plus sign, and I'm going to draw an arrow so that you recognize that this plus sign right here is this guy right here. Okay? Plus, and then 1 times x plus z is still x plus z. Now you have to look and see if there's any like terms that you need to put together. To me, it looks like the z's, you have a minus z and a plus z, they're gone. You have an x plus a x, which is 2x. And that is over the common denominator of x minus z times x plus z. Now, if you multiply these two together down here, it's not going to hurt anything. It might make it look a little smaller, but you do not need to multiply these together, and I recommend that you leave these separated because that is what the book is going to do also. So this is your final answer for number 50. Now we're on to 52. You have an x minus 1 and a 1 minus x. They look so close. And in fact, they are really, really, really close. For instance, this is what you would do to answer this question, since they are really close. I mean, really, it's just a matter of, this one has a positive x, this one has a negative x, this one has a negative 1, this one has a positive 1. They are really close to being the same, but they're not the same yet. The first fraction can stay the same. I'm going to take the one that kind of looks backwards. It looks backwards, 1 minus x. It really doesn't matter which one you take, but this one kind of looks backwards. What I'm going to do is I'm going to factor a negative 1 out of 1 minus x. What that means is it's going to turn a negative x into a positive x, and it's going to turn a positive 1 into a negative 1. And we'll just check that real quick. Negative 1 times x makes negative x. Negative 1 times negative 1 is positive 1. This negative 1 can be shifted up to the numerator. So your problem really here now is 2 over x minus 1 plus, let me make that look a little bit better here. I was getting ahead of myself, wanting to show all the steps. 2 over x minus 1 plus, this would be, when you shift this guy up, this is 1 times negative 1, which is negative 1, over x minus 1. The denominators are now the same, so all you have to do is add 2 plus negative 1, which is 1. And your final answer is 1 over x minus 1. And that is complete. And we have our last problem, which is number 58. Now, number 58 has trinomials in the denominators that need to be factored. So let's see. Let's go ahead and factor. Set up our parentheses here. So we have negative 3 over. The signs have to be, since it ends with a negative, they're going to have to be plus and minus. We have to have m times m makes m squared. We have to have 2 times 1, and we need the middle number to be negative 1. So the 2 is the bigger number, therefore it has to be negative, and we'll have 2 and 1. Over here, minus 1 over. We have to set up our parentheses again. Our signs have to be plus and plus. And we'll have to have m times m. And 2 times 1. And 2 and 1 gives us 3 in the middle. So we have to look and we have to see what exactly each fraction needs. Okay? At this point, they both have m plus 1s. But this one has an m minus 2 and this one has an m plus 2. So I'm going to kind of squeeze this in here so you can see this on the step, and we'll put it together on the next one. This fraction over here is going to need the m plus 2. It does not have an m plus 2, even though this guy has one. But whatever you do to the denominator, you have to do to the numerator. This one over here does not have the m minus 2, so it will need the m minus 2. But whatever you do to the denominator, you have to do to the numerator. So let's see what is left here. First of all, at this point, the denominator for each of these fractions, they both have an m plus 1, they both have an m minus 2, they both have an m plus 2. Let's make sure I didn't miss any here. M plus 1, m plus 2, m minus 2, m plus 1, m plus 2, m minus 2. They all have that common, so that is the common denominator for this problem. We're going to take and we're going to distribute the negative 3, which would make negative 3m minus 6. This minus sign, technically, I'll change colors here. Actually, I'll leave it, since it's already red, I'll leave it there. This minus sign technically can be distributed so that you make a plus sign here, but this becomes a -1. And I'm going to distribute that. So really what I'm getting at is there is a plus sign right here, and I'm going to write it right there. There's the plus sign. But this is now a -1 to be distributed, which is -1m, and -1 times -2 is +2. So now you have to look and you have to see what's left over here. We have a -3m and a -m, which makes -4m. We have a -6 and a +2, which makes -4. All over m plus 1 times m minus 2 times m plus 2. Now, if you got to this point, I would be pretty happy, but we've got to know that it's not quite, it may not be quite done just yet, because you have to recognize things like these are both -4s. If I pull a -4 out of those two terms, doing the greatest common factor, you're left with a +m, and you're left here with a +1. Check that. -4 times m is -4m. -4 times 1 is -4. And look, we have an m plus 1 down in the denominator. So technically there was more reducing to do in this problem. So I'm going to change colors here. Go to my red. And just like the earlier problems, the m plus 1s will cancel. And our final answer to the question turns out to be -4 over m minus 2 times m plus 2. And that completes this problem, and that also completes this video.